The story of antibiotics is a fascinating journey of human ingenuity and scientific discovery, shaping modern medicine and the ongoing battle against bacteria. The tale spans centuries, beginning long before the term antibiotic was even coined. Ancient civilizations like the Egyptians and Greeks used molds, plant extracts, and other natural substances to treat infections. For example, the Egyptians applied moldy bread to wounds, unknowingly using the power of penicillin-producing molds. Although they didn't understand the science behind it, these early remedies laid the foundation for the modern concept of antibiotics. Fast forward to the late 19th century, when scientists like Louis Pasteur and Robert Koch observed that some bacteria could inhibit the growth of other bacteria. This phenomenon, known as antibiosis, set the stage for further discoveries. In 1897, French student Ernest Duchesne noted that molds could kill bacteria, but his work was overlooked for decades. The true breakthrough came in 1928 with Alexander Fleming's discovery of penicillin. Fleming, a Scottish bacteriologist, noticed that a mold, later identified as Penicillium notatum, had killed the surrounding bacteria in one of his petri dishes. This marked the birth of the first true antibiotic. But it wasn't until World War II that penicillin was mass-produced by scientists like Howard Florey and Ernst Chain. The widespread availability of penicillin saved countless lives during the war and ushered in the golden age of antibiotics. This success sparked a global hunt for new antibiotics. During the mid-20th century, scientists discovered several important antibiotics, including streptomycin, tetracycline, and erythromycin. Streptomycin, discovered by Selman Waksman in 1943, became the first effective treatment for tuberculosis. Waksman also coined the term antibiotic to describe these compounds. The mass use of antibiotics transformed healthcare. Surgeries became safer, childbirth less risky, and infectious diseases that were once fatal became manageable. Antibiotics contributed significantly to increased life expectancy in the mid-20th century. However, the miracle of antibiotics came with a major drawback: antibiotic resistance. As early as 1945, in his Nobel Prize speech, Fleming warned about the danger of overusing antibiotics. His concerns became reality as bacteria quickly developed resistance to penicillin and other antibiotics. Methicillin-resistant Staphylococcus aureus, MRSA, for example, appeared in the 1960s, becoming a significant challenge for healthcare providers. This ongoing battle between antibiotics and resistant bacteria has been termed the antibiotic arms race. Over the years, pharmaceutical companies have struggled to keep pace with evolving bacterial resistance, and by the 1980s, the discovery of new antibiotics had slowed. The rise of antibiotic resistance has been fueled by overuse and misuse, both in medicine and agriculture. In many places, antibiotics are overprescribed, and in agriculture, they are often used as growth promoters for livestock. These practices accelerate the development of resistant bacteria, leading to the emergence of superbugs, bacteria resistant to multiple antibiotics. In response to this crisis, there's been a global push for responsible antibiotic use, or stewardship. Healthcare providers are being trained to prescribe antibiotics only when necessary, and patients are being educated about the importance of completing their courses of treatment. Research into new approaches to combat bacterial infections is also underway. Scientists are exploring narrow-spectrum antibiotics, which target specific bacteria without harming beneficial microbes. There's renewed interest in phage therapy, which uses viruses to target bacterial infections. Genomics and artificial intelligence are also being used to discover new antibiotics, helping to speed up the process of drug discovery. The future of antibiotics may involve more personalized approaches to treating infections. CRISPR technology, for example, could be used to edit bacterial genes and selectively kill harmful bacteria. The microbiome, the community of microorganisms living in and on our bodies, is also being studied to develop treatments that preserve beneficial bacteria while targeting harmful ones. Despite the challenges of antibiotic resistance, there's hope. Governments and organizations are incentivizing antibiotic research through grants and prizes. Public education about the proper use of antibiotics is helping to slow the rise of resistance. The story of antibiotics reminds us of the importance of scientific curiosity, responsible use of resources, and international cooperation. The discovery of penicillin and the many breakthroughs that followed saved millions of lives, but the ongoing challenge of resistance shows that the story of antibiotics is far from over. The next chapter will depend on how we adapt, innovate, and continue the fight against bacterial infections.